Hello, everyone. Can we get started? Please take a seat. Move forward, everyone. Please come forward. Chairs on you. So, thanks again for coming tonight. Appreciate everyone taking the time to attend this talk. Before we get started, I'm just going to invite Spencer from Keyboard. So, Keyboard has sponsored everyone as a group. So, I'm going to applaud Keyboard. I promise to be brief, but I have to just because my company is sponsored. You guys like the food? Is it? Thanks for coming. Just a few sentences about Cubolt. We are the big data software platform, data platform. We make it easy to do big data. We support multiple data engines. Of course, Hadoop, Hive, Presto, and Bolton. She'll talk about Apache Spark. Use cases range from ETL to machine learning. Our software, we have a free edition of our software, so go to cubolt.com and try it out. Thank you. For another thing, we have a raffle going on, so if you didn't fill it out, we're raffling off 2 Amazon Echo and Holden's book. One of Holden's, she has 2 books, but we're going to raffle off her latest version. So make sure you fill out the raffle slip at the back. You can see Ashley, she's wearing the white Cubolt shirt. And we'll do the raffle after Holden's talk. We have cookies and other things. Thanks, Spencer. Without further ado, I just want to introduce Holden. She's been in the Spark community for quite some time, and I'm glad to have you. Thank you, Holden, for coming down. Round of applause for Holden. Yay! Lovely. Okay. I'm going to take a picture of the audience really quickly, and look, this is fun and interesting. That'll make me see my boss that I'm doing work. Okay, cool. Or maybe it'll look bored, I don't know. So I'm going to talk about an introduction to Spark machine learning, for people who aren't super familiar with it. And then for the second part, I'm going to talk about how to go beyond sort of basic algorithms built in Spark, what to do when you find the tools just aren't fitting. And of course, because I'm an open source developer, I believe the answer to the tools aren't fitting my needs are to make new tools and share them with the world. And okay, yeah, so I'm hoping my preferred pronouns are she or her. Tattooed on my wrist in case you forget. I'm a principal software engineer at IBM's Spark Technology Center in San Francisco. Mike also be very upset with me if I did not tell people we were recruiting. So if anyone's interested in relocating to San Francisco, I realize this may be a tough sell to SoCal folks. But if you like fog, and I'm sure there's other nice things, come talk to me. I'm a Spark committer. That part's pretty recent, but I've been working on Spark for probably about 5 years.
The microphone is not working. Do you mind say a little bit raising voice?
Rocking. Okay. Can people hear me at this level? Yes. Okay. A little bit. I'm going to try and talk at this level. I am not used to doing that, but hopefully this doesn't upset the people in the front row. I'm sorry. So before IBM, I worked at a bunch of random companies. Lots of fun. Tiny startups will either redeem or destroy your soul depending on who you're working for. Before that, I worked at Google, Foursquare, and Amazon. Oh, I guess Foursquare. Actually, yeah, I checked this morning. Foursquare still exists. I have no idea how. I'm a co-author of a few Spark books. I have a new one. It's called High Performance Spark. The royalties on that one are a lot better than any of my previous ones. So this is the one everyone should buy. Don't worry, there will be frequent product placements throughout this presentation. Not a lot of my employer, but just if you want to follow me on Twitter, it's just my name. The slides from tonight's talk will go on SlideShare, and I also have a lot of other talk slides up there as well. So you know, if you want to check that out there. LinkedIn is really not very useful. GitHub has some of the code associated with this. I made a companion notebook for people who are interested in following along, and someone else ported it into Scala, but I'm sure it probably works. The Python version definitely does. The Scala version. In addition to myself, my co-presenter, her name is Fu. She has appeared before the Texas House Committee on something really quite awful. They did not listen to her. But she has lots of public speaking experience as well. Her main experience is barking at computers to make them go faster. And she is the author of High Performance Barking and is on Twitter at @foodprogrammer. Generally, she tweets about happier things than me because when you're just barking at computers, you don't tend to get too upset with the stack traces. We're barking at a computer. So in addition to work, and I'm trans and queer and Canadian, I'm here on a work visa, which is being debated as to what people want to do with. And that's just a great time to be in America. And I'm also part of the leather community. If you don't know other people like me in your industry, you should come up to San Francisco more often, but I suspect this is LA, you probably do. But just a reminder, like, we all come from different places. You know, there's no secret Canadian plan. Well, there was one, but it was not a very good plan to take over America. And we haven't had a secret Canadian plan to take over America in a very long time. So please, like, be friends with your coworkers, regardless of their background. If we all work together, instead of yelling at each other on the internet, we can write our shitty code faster and get home and see our partners, or go to Disneyland, or do whatever it is that makes happen. This is my employer slide. If you are the kind of person who makes decisions about buying things from IBM, please continue to buy blue. We have a lobby. It's not blue colored, but it is green colored.
and green is the color of a passing Travis bill. And so this green lobby signifies quality software. This green lobby also signifies that my boss has the ability to tell me to put a slide in my presentation, but forgot to tell me what to say about it. So I work in the Spark Technology Center. We focus on open source. We are in San Francisco. I work with a bunch of other developers. There's some co-located designers. As you may have guessed from looking at the slides so far, they tend to work on software, not slides. They don't touch my slides. But we do a lot of focus on Apache Spark. We've got some new fun things in the pipeline that are also open source, but somehow are also secret at the same time. I don't really understand how this works, but I'm really excited for some of our secret open source projects. That will become less secret with time. Okay, great. So what are we going to explore together? I'm going to talk about some of my assumptions about who you all are. Since this is a Spark meetup, I made some assumptions about the background of folks. But if I get a lot of really blank faces, we can switch things up a little. We're going to talk about the two different machine learning APIs that are built into Spark. We're going to sort of explain why I'm only focusing on one. We're going to talk about how to use one of them. And then we're going to jump into how to extend it and how to make new cool things happen as part of machine learning. I'm going to finish with some take-home exercises. These are incredibly optional, and I really don't expect many people to actually do any of these exercises. But if you do, you can email me, and I will send you a sticker reminder. It's just like grade school, but with Python, or Scala, depending on your personal preference. And then we will finish up with a raffle and cookies from our good friends at Google. I hope I spelled your company name correctly. Yay! Okay, awesome. So we are focused on Spark machine learning today. The new Spark machine learning libraries are built on top of this thing called data frames. But it's important to know that even though I'm only really talking about data frames and machine learning, there's a lot of other things inside of Spark as well. And in Spark 2.0, we actually have even more things. We have this machine learning library, we have SQL, we have structured streaming, we have a collection of language APIs, very useful to get actual users. We have a collection of graph tools that don't work. We have this old machine learning API that I pretend doesn't exist. And we have community packages, which we'll talk about today. And I'll try and get some of you to make a community package. Once again, my hit rate on this is about like 1 meetup to 1 community package. So it's a pretty low success rate, but I'm hoping we can do this. And then there's this core execution engine. It's awesome fun. So you're all nice people. You've laughed at many of my jokes. Some of you even seem to like your coworkers from different backgrounds, so that's cool. I'm really curious, how many people have worked with Spark? Okay. For how many people is this your introduction to Spark? Is this your first Spark? Okay. So like 7 people. Okay. So I'm not going to spend a lot of time doing in the introduction material since there's only 7 of you. But if this talk doesn't scare you away, or if it at least seems like maybe it grabs your interest and you're interested in learning more, Paco has a really wonderful free Introduction to Spark series on YouTube. It's really great. It's a 5-hour-long video. You can watch it at 2 speed if you want. It's really good. It can finish in less time than your MapReduce job will take. So, I encourage you to go and Spark. Okay, how many people are Scala users? Consider themselves Scala users. Not a lot. Okay, or the Scala users are just really shy. That's fine. Who considers themselves a Java user? Okay, and is Python making up the remnants? Okay, and how many people consider themselves primarily or exclusively an R user? One hand? Or is that raising loud? Okay, one hand. Okay. We are going to focus on Scala and Java and Python. But the first part of it, which is using the pipelines, will be applicable in R. Extending the pipelines in R is something which doesn't work yet, but if you want to make it work, I can introduce you to the people who are working on that. They're mostly out of Seattle, but they're really nice people. And they're wonderful. So, if you read the meetup description, you might have saw that there was a companion notebook you can follow along with. It's completely optional. If you didn't bring a laptop, don't feel bad. If you didn't bring a laptop and your burrito is more tasty than your keyboard, that's totally fine. But if you are going to follow along, it's going to be useful to have Spark 2 or higher. Spark 2.2 is probably going to be the one you're going to want to use, but Spark 2 or higher. There are some exercises in the notebook, and at the end of the talk, because I want this to be interesting to people who didn't bring a laptop, I'll go through the exercises at the end, and you can sort of see how to understand it. For the people, oh crap, that might be my own fault. No, that's someone else. Sorry. Okay, lovely. So if you're interested in following along, here's a lot of links. The really important one is just this really long one that I probably should have shortened. I did it every other, well, not every other one, but this is the GitHub repo where you can find a companion notebook, and the Scala version should be in there as well. And if it isn't, I'll fix that at the end of the night. But the Python version is definitely in here. You check this out and follow along. And so we're going to pick some really, really simple machine learning stuff, mostly because at the start, I find it's nicer when I can succeed. And also, I tend to not like things which depend on meetup or conference Wi-Fi working for extended periods of time. So data sets which I can solve locally without being connected to a cluster. Even though Spark trick solves with the actual like distributed ones, for the notebook, we just go with this really simple thing. It's in the GitHub repo if you want to just download it yourself, though, play around. So what are the two Spark machine learning APIs? So there's like the traditional one and the pipeline one. The traditional API works on Spark's resilient distributed data. And for the people that are new to Spark, you can just think of that as a generic distributed collection. And there's a magical unicorn inside of it. And the magical unicorn commands an army of 100 gnomes to do all of the work on different gnomes. Each gnome does a part of the work, and you don't have to ask any questions as to why there's unicorns or gnomes hiding in your data set. The pipeline API, which is the new fancy one, works on top of these things called data frames. If you're coming from a Python or R background, you probably have this idea that data frames are really awesome and useful. And the idea that a distributed data frame is really exciting. But I don't see a lot of excited faces, which means either you don't come from a Python or R background, or you've already been exposed to the disillusionment that is Spark data frames. And that is, it has all of the structure of a data frame that you might be used to from Python or R, but none of the functionality. So you have this wonderful distributed collection, but the set of things that you can do to it is really quite limited in comparison to what you could do with something like pandas. But that's okay, because when we run into those things, we can often implement them in terms of primitives ourselves. It's not too much work, but it's not the magical pandas data frame on a cluster. That project is called PATS. Right. So the catch with data frames in comparison to RDDs is that, like traditional pandas data frames, they have sort of a restricted subset of types that they work with. Most of these types are types that you would expect. If you're going to try and take a random number generator and put it inside of a data frame, you're going to have a bad time. If you want to put a bunch of randomly generated data in your data frame, that's fine, right? Whereas Spark RDDs pretty much take the view of, if I can serialize it, why not? And it turns out there are very good answers to the why not part. Just because I can serialize a database connection doesn't mean it's going to make any sense on the other side of the wire. So, you know, but so data frames are often pretty good. They tend to be able to represent most of the data types that you're going to be interested in. They have a slightly restricted set of operations that you can work with in comparison to RDDs, right? But we've actually done a pretty good job. Most of the functional transformations that you're used to from RDDs on top of data frames, but they have a little bit of a cost compared to the specialized data frame operations. And they have a lot of really cool future optimizations in you're the kind of person that likes reading academic papers or looking at in-progress C++ and Fortran code, I encourage you to check out Untitled Chapter. They're really fun, and I'm really actually quite excited about Apache Arrow. So now, well, I mean, I work for a vendor. I don't actually know how to sell you anything from IBM. But you should still not trust me because my financial incentives are aligned with convincing you to use Spark. But it's okay. You came to a Spark meetup. You've probably already been sold on the idea that Spark might use it. This is where I try and convince you that data frames might be the solution to your problem. And here the runtime is arguably smaller numbers are better unless I'm billing you by the second. If you're paying someone by the second, you really want to be using data frames. We can see this is computing a really simple aggregate, which is pretty common after doing a machine learning algorithm. After we've computed our loss function, I need to aggregate it together. And so when it takes a long time in RDDs, that's kind of not great. And so the blue is like well-written RDD code, and the red is really written RDD code. And the like yellow is just the easily written data frame. There's probably an even better way to do it in data frames, but it just really wasn't working. So low numbers are good. Please buy 6 data frames. I mean, it's open source and free, so whatever. But okay, now on to Spark machine learning. Yay, the part we're all here for. So Spark machine learning uses Spark data frames with many asterisks attached to using a data frames. But its Spark machine learning pipelines are scikit-learn inspired, which is really exciting because the scikit-learn people are quite smart, and they came up with a really wonderful API. The traditional Spark machine learning API was very much like, I built this cool machine learning algorithm. What do you mean data preparation? Don't you just download the data set from the challenge website and submit your results back? And the Spark machine learning thing is what happens when researchers encounter real data and then they get sad. But then after they've been sad for a while, they make another thesis and produce machine learning tools. So in addition to like, I mean, NiaGBase isn't really a fancy machine learning tool, but in addition to like traditional machine learning tools, we also put a lot of things on like, hey, maybe you have English data, or maybe you have something with text in it. You might want to turn that into a feature. So let's have some featureization. So there's tokenizers, there's caching transformations, there's lots of things. Normally, I mean, I spend all of my time, well, not all, but enough of my time in America that I get to pretend that the space tokenizer works really well. But people who have to go outside of America or occasionally deal with data from outside of America, but the nice thing is you can put all of these things together into a single system. So rather than having like one program to do all of your feature prep and another program to train your fancy machine learning tools, build this one program which has all of these pieces together, and it's awesome. It's nice and happy. So pipelines can be either, so pipelines consist of stages. Hopefully we don't spill data out of our pipeline. But so it's an estimator or a transformer for each stage. An estimator is something which has to see data. So traditionally we think of a machine learning stage as an estimator, but something like a stream indexer can also be an estimator. So if we have to see a bunch of sample records to figure out what we're doing first, and that's an estimator. Tokenizers, because once again, English, I like to pretend that's close enough to represent every sample of the world. Not, but I can just do that purely on my input data. I don't have to train my model. And so I can construct my Spark ML pipeline, call this fit function, and then I get this pipeline model that's been fit with all of the different stages in it together, and I can start using this to predict things. Also really cool, because I didn't do very well in my statistics class, I can also point a parameter grid search at this and say, hey, what's up? I have no idea how to pick my model parameters, and there's a bunch of different stages, and they all have 6 different things that can be configured on them. Let's just pretend that this parameter space can actually be searched in a reasonable amount of time. go and find a good set of parameters for me. And then afterwards, I pretend I haven't like overfit my model and I ship it to production. And find out that I probably should have reserved a test set before I did that. But you know, it's okay, right? Like right. So estimators and transformers, they both have to provide this transform schema function. Don't worry about it too much. We'll talk more about the sort of implementation details as we go. They also tend to have parameters for configuration. So when you're constructing your stages, you tend to have to set things up. So the naive is, or actually, let's not go with naive. For religious regression, I tend to have a regularization parameter that I want to tune. So the parameters are configured in a standardized way across the different model types so that I can do things like my parameter search. It's convenient. It also makes it a lot easier to blame developers for when things go wrong. Because if I don't provide any knobs to tune and my algorithm performs poorly, then it's really clearly my fault. But if I give you a lot of knobs to tune and it performs poorly, you selected the wrong knobs and I'm out of office for the next week. Good luck. Right. So how is a transformer made? So we either have things which start out their life as transformers, or we have an estimator. What happens is the estimator and the data get together and they spend some time on a cluster. After they get to know each other, the Spark context, which is the stork in this case, comes and delivers a nice, beautiful transformer. I thought that was going to be funnier. So essentially, what happens is our estimators are fed some data, and, you know, and then we get a transformer. Okay. So we're going to use this to build a really simple function. We're going to start off by loading some data. Ignore this part. And I remembered to go with the part in red. We're going to load the sample data that I was showing people earlier. The Spark packages, Spark CSV package is out of date. You don't need it anymore unless you're on an old version of Spark. And if you are, this is the magic incantation. But none of you should need this. So let's just move right along and ignore that. So when you want to load data in Spark, you can call SQL context.read, and it gives us back a data frame. If you're in the new fancy Spark 2.2 land, you call Spark session.read, and it gives you back a data set. Which fundamentally, even though we changed all the names, does exactly the same things. You can specify the properties for your input data. It's a pretty standardized thing. So here, for example, I've got some CSV data. I want to look at the header. I don't actually know what my data looks like because people are always lying to me, so I tell them to be for the schema. And then this is where my data lives. For example, this data, you know, here it lives locally, but this could live on each DFS. It could live in S3, it could live in whatever sort of distributed storage. That picture was supposed to come out more clear. This is supposed to be birthday Soros with the Disney birthday button. Well, yeah, okay, so then we load our data, and birthday Soros is happy because now we have some data to train our model on. And so we're going to train a decision tree. Yay! But first, we have to select our features. We loaded some data in from CSV. We have to tell Spark which of these things it actually matters. And what of the things are going to be our labels, because otherwise, you know, has no impact. So the simplest data prep cleaning stuff is honestly just pretending that our data is already clean and putting it together with the vector set. So we're going to start there. And this essentially, we just construct a feature vector of doubles and Spark can just train on this. So we import a decision tree classifier. We could do the bucketizer. We'll use the string indexer in a little bit. We're not going to use that for a feature. We're going to use that for our label. And then we want to put it all together in a pipeline. So we put this pipeline. So simplest step is, the first step is, I'm predicting things about income. And thankfully, I've got age information and a numerical representation of education. I tried reading how they produce that, and it just made me sad. But so I have some type of numerical scoring of education of individuals. So I'm just going to put those two together in a feed column, and maybe we'll find out that like older people with more education make more money, or alternatively, we'll find out like people exactly my age with not a lot of education make more money, in which case I'll go to my boss and ask for a raise based on his decision tree. But we also, we've got these categories about whether or not people make above or below a certain amount of money, and that is expressed as a string. And the problem is, Spark's machine learning pipelines, we made we assumed that things were going to always be doubles, and it turns out that that's actually a really shitty assumption. Especially for things where we're predicting labels rather than continuous numbers. Like we tend to not have gender tends not to be easily represented as a numeric 1.0 or like negative 1.0, right? That doesn't make sense. We tend to have free text stuff pretty often for labels. So we can go ahead and we can take this and we'll just map each individual specific unique string to a different numerical value, and Spark will be able to do this as well. Because we're not doing regression, it doesn't really matter what the mapping is because this is just a classification problem. The mapping to these arbitrary numbers is purely arbitrary. And then I make a pipeline, and my pipeline has my two little feature components on the side of it. So I've got an assembler and an indexer. So a bit more about our pipeline. So each of the components that we made have either a fit or transform. That should be more fun. When we fit this, though, what happens is if any of these components could be fit, Spark will fit it. So if we think back to here, when we call fit on a pipeline, Spark goes through, says tokenizer, now that's fine, just copy that over. Hashing TF, copy that over. String indexer, oh, okay, I have to train it. Fits it, takes the result, copies it over, and transforms. And then it fits the negative phase, copies it over. It's fine. So it essentially just lets us instruct it away. So we go ahead and we take this pipeline, we fit it, we get back this thing to prepare our data. So our pipeline is maybe not super exciting. We've got some input data, and the assembler comes along, makes this input data and vector thing. We call the string indexer, it gives us the input data, category IDs, and vectors as its result. So the interesting thing to note here is that we just keep adding new things. We're not getting rid of any of the old things. So the vector assembler produces vectors of the parts we're interested in, but it doesn't throw away its input. It just sort of appends onto it. And that's really important because right at this stage, we still haven't bothered to encode what it is we're actually trying to do. Right? We haven't encoded our category information. And so if we threw away our inputs, we would be, kind of up to date with that how. The downside of this, though, is if you produce a lot of intermediate synthetic features, so if I have like the interaction of these two things and the interaction of these two things, and I produce all of these intermediate features, I can get these really, really big rows. And I mean, that's fine, but if I don't actually need my input data at one point, I can be shuffling these big rows around even though they're no longer useful to me. And so one of the things that you actually may want to do before you fit your fancy machine learning model is add in a pipeline stage to throw out the pieces you don't actually need for fitting your big model, because then it can be a little bit more. Yeah.
Do you have a transformer that you draw?
No, you got to write your own, and I'll show you how to do that. Because we really should have put that in there, but we didn't. But it's really easy to write. And if you want to write it and put it in this open source project that I'll tell you about in about 10 minutes, you can be contributor number 3, and you can get 2 stickers. It would appear that sticker-driven software development does not work as well for other people as it does for me. I'm really glad my boss hasn't figured out that all he has to do is give me stickers. Because random sentences go, cannot be paid stickers. Right. So we need to, we've done our feature prep. We're going to go ahead and train our decision tree classifier. So we've got our labels, and we know what our features are. But if we just manually do this part, right, that's kind of sad. We fit our decision tree by hand on this prepared data. Instead, what we should really do is just take that pipeline that we constructed previously and put our decision tree classifier on that as well. So then I can go ahead and I can just fit all of it in one go. And yeah, so you have a really simple machine learning pipeline. Yay! If this was the valley, you could raise money. Based on this. I don't know. Like seriously, I look at the Y Combinator thing. Anyways, it's okay. I spend too much time in coffee shops in San Francisco. I've gotten a little bit jaded about how capitalism. So yeah, this slide is money. You have to like pick an industry and call yourselves X or Y plus this 5 lines of code, but then you're good. And the cat picture is indeed the same. But so we've trained a machine learning model, we've raised our VC money, but now the users are like, hey, so I gave you all my data, but you didn't give me anything in return. And you're like, that's normal. But then some of the users are like, I'm going to stop giving you my data unless you give me something in return. And you try offering them cat pictures, and they're like, no, I already have Reddit. I'm pretty good on cat pictures. So you offer to predict things for them. And that's okay. So we can take the results of our training and we can predict their results. This is a very long way of saying that once we've trained our model, there is indeed a way to predict things, because otherwise this would not be a very useful exercise, except in expecting money from them. So the pipeline API has a lot of different ones, or really stages, because they're not all models. There's binary logistic regression, classification, there's like GPT regressor, there's all kinds of fun things. So if you're going down the path of like trying to implement some cool machine learning algorithm in Spark, check to make sure that someone else didn't do it first, and you get away for free in open source package. Because if they did, your boss might actually have a direct point of comparison for your work. And I found that is a good way to have a lot of awkward questions and answers. So I prefer to look at this and then go, I'm going to implement something slightly different. So yay! In addition to the ones that are built into Spark, you can also look at Spark packages. You might notice, if you're the kind of person who's trying to raise venture capital, that none of these things say deep learning. But that's okay. On Spark packages, there are a collection of deep learning tools available for you to plug into Spark. But once again, if you want to raise venture capital, you probably have to do your own custom deep learning tool for Spark, so we'll talk about how you can do that and raise millions of dollars. More realistically, if you actually want to do something useful with your life, you might actually just need to build some better feature preparation stages, right? Like, you could be fine with these things, but your specific industry data might not be well suited to these types of machine learning models, and it might need a little bit of cleaning preparation, right? Like, null could maybe be used to represent 3 different things depending on different states in your input. I know no one has that problem, and you might need to do something intelligent with it. Or you might have JSON data and you need to like reject a bunch of records before you're training it because Bob, who produced your upstream data pipeline, likes to go drinking on Fridays and push code to production. Right? Like, there's a lot of things that Spark isn't able to handle that are really specific to you, and that's where we can see. Yeah, I think feature prep stages are really where we should be focusing ourselves to start with if you want to extend Spark. If you don't want to extend Spark, that's fine too. You can use all of these wonderful tools. You can use the tools that I will hopefully trick you into making at the end of the okay, by the end of Q4. Okay? Okay. So this brings me to my next wonderful slide about what you can do to help make more wonderful tools. So I have this new project called Sparking ML. We're definitely a real open source project. You can tell I got stickers made. And it's a place for useful Spark ML pipelines to live. And this is because one of the things which really makes me sad about being a Spark committer sometimes is telling people no. And I mean, like, don't get me wrong, sometimes I like telling people no. Like, when they ask for things that are just wrong, okay, like, I don't feel so bad telling people, like, no, I'm not going to change the API to support mutation. We really can't do that. We just can't support that. Here's the paper on why. It's a long story. But on the other hand, when people are like, I made this really cool machine learning algorithm, and I'm like, I have no idea what the hell you were doing. It looks really cool, but like, I'm pretty sure you're going to graduate from grad school soon, and then no one's going to be around to maintain this, and we can't take their code and make it available to the world, so we have to tell them to go and make a Spark package, and sometimes, wait, oh, this is being recorded. That feels like telling someone to go and be sad, instead of a different word. Yes, so instead we can all come together and we can work together in this place called like Spark ML, which will hopefully be fun. We can try and help each other, and we can be a little bit more lax than things that go into Spark. Right? So this could be a place for like good feature prep tools that maybe don't belong in Spark.
Also, no relation with sparkling water.
No relationship. Yeah. Those people have a much higher marketing budget than I do. So they also they probably could stickers. It's true. Oh crap, this is being recorded. Yeah,
Up to versions.
Yeah. Okay. So they're wonderful people. They're great, and they're definitely not influenced by trying to get you to use their commercial product whatsoever. Is that believable?
Yes.
Okay, cool. Everyone believes it. It's great. My boss seems to follow me. It's very frustrating. But now we're going to start on our adventure. It's our adventure to extend Spark ML. And honestly, if you are here from Spark and Water, like, thank you for your work. Like, your stuff is actually very good. It's just, you know, very much off in its own corner. It's not implemented in the standard way, so we can all work like together. But Miffy believes that we should write our code in an open source fashion and make sure that we implement the standard API so that we can all play together and not make walled gardens, because she can't plant tulips in walled gardens. This is starting to be okay, so we have a duplicate slide, and so this is a great time for you to do. But so as a quick reminder, the bare minimum to implement a pipeline stage, if we're working in Scala, there's this thing called transform schema, a function called copy, which we'll talk about in a second. And if we're making something like fancy, like an estimator, we have to provide a fit function, or if we're making something a little bit simpler, and I don't mean simple at all in a bad way, just like not as complex or involved, we're making something simpler which doesn't need to be trained on data, just provide a transform function. Often, once again, we should provide parameters for configuration so that when things go wrong, it's not our fault. Otherwise, you know, your pager goes off at 2 o'clock in the morning. So you may have thought that by coming to a machine learning workshop, or well, not workshop talk, you were going to get away from the word count example. But I regret to inform you that as a licensed big data instructor, I cannot give a talk without the word count example. So here we go. We are going to implement the word count example inside of Spark ML pipelines. This is completely useless, but does demonstrate the API. And it also allows me to retain my big data instructor license. Very important. So the simplest thing is we have this hard-coded word count stage, and we extend the transformer base class. We provide this copy function, and this copy function just calls default copy. Essentially what this is if our stage had a bunch of parameters that were passed in here, we would make a new version explicitly. But since we don't, all we have is this UID being passed in. Default copy is fine for us. So if we had like information about what we had bid on, for example, if this was like there's regression transformer, we might have a bunch of weights here, and our copy function would have to be creating an instance of us. But don't worry about it. You can just go find a copy function, something kind of similar, copy and paste it, change it a little bit, and it'll be fine. If that doesn't work, go find an answer on Stack Overflow. It's necessary. But the transform schema function isn't something we can just copy and paste, except for the parts that are. I guess most of this is stuff. But don't copy it from my slides, they might be out of date. Copy it from the Spark ML repo, which you'll all be checking out later on tonight, I know. So transform schema is responsible for validating that our input types are the same. And you might be thinking, hold on, isn't Spark written in Scala? Scala is a strongly typed language. Why do you have a function responsible for verifying that your input types are the And that is because normally I very much gloss over this point because it just makes people sad when they realize what's happening. But our ML pipelines really don't bother with any compile time type. They just throw it all away. Because it was hard. Or more specifically, we implemented them back when Spark data frames didn't have compile time type information. And then once we added it back, it was really hard to make work. Because the types that we take could depend on what parameters it's set. So for example, if someone tells me to take an input column, the type that I need to check for example here, and verifying that there's an input column called happy pandas, very important. There are no happy pandas while processing this data. Could depend on how my word count state should be configured. If I told it to count information about sad pandas because I was a monster, then we need to check for it. So this is really simple. We check that our input types are reasonable, and then we tell downstream what our result types are. And this probably doesn't seem very exciting. The thing is, you have to implement it, and it is actually useful, right? Because the alternative is you build your fancy machine learning pipeline, train it, and then on the very last stage where you were renaming two columns, you got the column name wrong, and it fails after 23 hours. And while I wouldn't mind that happening like once in a while, I don't like working all the time. I would view that as a wonderful opportunity for a rest. Given the number of times I make those kinds of mistakes, I would much rather it was caught at minute number 5 as opposed to hour number 23. So this just allows us to verify that our types are going to line up at runtime, yes, but at the start of our run rather than at the end. I really should have had this slide up while I was telling you all of that, but here's a picture of a cat to make you feel better. And right, so for Python users, we didn't bother to implement that. I'm sorry. If you're going to do this in Python, just try and not make any mistakes. Good luck. Okay. So our actual work, this is where we do the HTTP version of word count. I split some things. But so essentially what happens inside of here is your business logic. This is the part where you can call Fortran if you're living in the 70s or have a support contract from the 70s. A surprisingly large number of machine learning libraries still use Fortran under the hood. Thanks, Jay Glass. But this is where you can put your fancy machine learning. Since this is a feature prep stage, this is where you can put your reject the records which have mostly non-records logic. Or this is where you can see it would be really easy, drop the columns that I specify. So that you can just do that and return your result. So you can do this, right? By the end of the week. Come on. It's tomorrow. No, Sunday. You work on weekends, right? It's open source. Okay. I'll harass you later. So for Python people, though, you might be like, well, that doesn't sound like fun. I don't want to do word count. Well, that's okay. Instead, we're going to take the length of a string and add the number 3 to it, which is really much more of a Python specific. But realistically, we have a very similar base, right? We have the same init. And our transform function does something very similar, right? Essentially, we can do whatever we want. In Python, it's, here I'm doing it with the user-defined function. You could do it with a map or a filter, but data set with column has some slightly better performance characteristics, which are a subject of another talk entirely. But this works pretty well, and you can call whatever Python logic, right? So normally what ends up happening is you end up calling NumPy, which ends up calling Fortran code from the 70s. Or if you're like one of those fancy people, you're trying to raise money, you call TensorFlow, do some fancy business logic, and out comes a business model. Or at least that's what I seem to understand. But you might be saying, hold on, this word count example, exquisite, definitely what I want to build, but I really need to be able to configure my word count example. The words I want to count are not about happy pandas. I am in fact a villain, and I want to count information about sad pandas. And that's okay. What you do is you add these parameters. And you might be just like, hold on, that's really quite reminiscent of Jupyter code. You have these setter functions that makes people sad, right? And seeing at least some people have drunk enough of the functional programming Kool-Aid that they can see set input column and go, but the reason for doing it this way, rather than just like writing here at constructor time, is that by doing it this way, we can use the parameter grid search or any express meta algorithms to search over the parameter space. And if we just set them here, we have to depend on like reflection and looking at the types. But here I get a bunch of annotation sparks, like magic stuff inside. If you didn't believe that, show you the code, it's really quite depressing. But the TLDR is when we construct our parameters this way, Spark is able to manipulate them once. The same thing is true in Python, except the wonderful thing in Python is because making things private in Python is really hard, you can actually just go ahead and use the input column, or sorry, use the parameters that are being used as base classes in Spark, and just hope that we never change. If you upgrade Spark, your machine learning pipeline might stop working, but it'll save you literally characters of type. So just go ahead and use internal APIs. You're extending machine learning pipeline, so you're probably going to bring this on. But alternatively, you can write your own thing here. This is how you can use the built-in ones. So the input column and output column are Spark parameters, and this one is our own custom one because Spark does not have something to add an amount to the string list. That's the default parameter that the other models use. It's very simple. Then we have our getters and our setters, just like Java beans in the 90s. It's very old school. 90s are coming back though, so it's an exciting way to code. Right. Meta algorithms, meta algorithms. Meta algorithms is not quite developers. It's close enough. If you're wondering what parameters your model should provide, you should probably go back and read the paper to the person that wrote the Fortran code that you're ripping off read to write the Fortran code. Alternatively, you can go ahead and look at the parameters that other Sparks, other models implement. Just pick some of those. In Python, we can just go ahead and use them because we can't private. It's hard. And so that's all well and good, but you might be saying, Holden, unlike you, right? Some of these people might be willing to put more than just 3 days into implementing this. They might be going, Holden, my boss really has no idea what to do. I want to go and spend a month implementing an estimator. I think I can make a better version of logistic regression than anyone else out there. If you can, there is someone on Wall Street who will pay you a lot of money. It's not me. But you can go ahead and make an estimator. You can go and tell your boss it's very important for business reasons that we implement this custom machine learning. And pretty much you do exactly the same things we were talking about, except instead of providing this transform function, write a fit function. The fit function produces some parameters. It constructs a transformer with those parameters, which then provides the transform function. Let's look at a really simple one now. So here we've got this string indexer estimator. Cats love it. So we put some implicits. We've got this wonderful $sign. That's very reminiscent of Perl code, if anyone is Perl programmers in the house. Ah, friends! Friends. Normally people are more ashamed about their Perl past, so I feel like we should all be friends. And the like 6 people in the room who are like, knowing what I'm developer now, you should also come and hang out with us. But the nice thing is the $sign has made a comeback because the people that work on Spark keep finding language features and going, why not? And so this is how we can access the values of our parameters that users have configured. We can also just use the get function and pretend we're writing Java code. But here we select our data, I figure out all the unique words, and I construct this model. Here we can do something fancy. This is where your business logic lives. Business and logic both belong in quotes, obviously. But we still have to construct our transformer, so we didn't waste your last 10 minutes listening to me talk. No relationship to historicals. Yeah, so simple transformer. The important thing here is the parameter which is passed into us from our estimator is not a Spark parameter, right? It's not a Spark machine learning parameter, it's just a class constructor parameter. And that's because we don't want users manually setting values on their logistic regression. Transformer, because then everything goes to hell. And I can't blame them for things anymore because I gave them too many knobs this time. Pardon me. I'll still blame them. It's all right. But other alternative, if by reading Fortran code and sort of re-implementing all those single variable names in Spark with underscores is about as appealing as a rusty spoon to the eyeball. It's important to get that one right, of course. Is my friend Seth Hendrickson, who sadly left me for Cloudera. And are there any Cloudera people in the room? Okay, I will shake my fist on the recording. Damn you for stealing Seth. Seth, I hope you're having fun there. I'll see you at the Spark Summit. But he has some interesting work around pluggable optimizers. So if you can write down your cost function in a reasonably parallelizable way, he has some different optimizers, and you can try these different optimizers across your cost function and see if it results in reasonable parameters for your model. The pro tip here is a little sad. Spark's data frame and dataset optimizer performs really poorly on iterative algorithms. Machine learnings algorithms tend to be iteratively optimized algorithms. So even though we do work with data sets a lot, we often have to convert the data into RDEs intermediately to essentially get out of the optimizer's way, to force the optimizer to get out of our way, because the optimizer makes more mistakes when we're doing this iterative step. But in other places, using the data sets is reasonable. If you have a closed form solution, that is great. Implement that, have fun, be very thankful you don't have to do an iterative optimizer. You're very lucky person. So you've made your model. That's great. Hopefully you open source it. You could put it in an alpha flag. You could even compare it against some alternative models. And this is only a thing to do if you are really secure in your employment. So if you spend 3 months making a custom model, and then you go and you compare it against the stock logistic regression, and then you perform worse, you better lose that report. But if you are curious and you want to see how they're doing, Spark has built-in cross-validation tools. Other keep one out, and you can test to see if it's working well. You should probably implement persistence. But honestly, I'm using my voice at this point. You're all probably losing attention, so we're going to go ahead. Please contribute your fancy models to Spark ML. We would love to see other people there. Alternatively, if you don't want to contribute your own logic to Spark ML, please just publish it to Maven Central, make it open source. I'm from Canada, so I am kind of a hippie. I think software should be free. I work for IBM, so I think software should be free with a support contract. But if you can, I would love it to see more open source machine learning tools from people outside of the Bay Area. I think there's a lot of really interesting work happening in other places that just doesn't get shared as widely. Please think of the Python users. For the one R user in the house, if you want to talk with people that are working on the R stuff up in Seattle, I would love to make an intro. Alternatively, if the idea of contributing to that is not making you excited, really understand. It's a lot of work. Yeah, great. So there are a lot of other things in the wild that implement these, right? XGBoost is a feature attribute. If you're interested in deep learning, insert EC capital here. MXNet and DL4J both implement Spark ML pipelines. To some degree, Intel's big, I don't remember what the hell they're called their thing. Intel's fancy deep learning method got halfway through implementing the Spark ML pipeline interface, and then decided that they wanted to be a special snowflake and not implement the standard API. So it looks really similar, but can't be used with most of the tools, which just makes me really frustrated, and I hope to convince them to implement the rest of it. But on the other hand, their code works, so it's fine if you're using it. Just don't get confused when it doesn't work like everything else.
So the previous is does about this stuff that are available.
Yeah, so these things are all available in the Spark pipeline interface. There's a lot more. Well, these are the ones that like sound fancy. And as someone from the Valley, like if I don't go to deep learning, shout out in my machine learning talk, my license to like I am not going to be able to pay that. There is a bunch of resources. I have an example repo for high performance Spark. There's some examples inside of it. There's no Riley radar post on how to do this. If you prefer blog formats, if you tuned out the part of my talking. Really sparkling ML. Right, so if you were doing the follow-on notebook solution, there's a bunch of things that you can do to sort of extend that really simple decision tree. The simplest one is getting useful results back from it, because all it does is predict numbers for you, and you have strings. So if you want to get this back, we're going to see the solution. The other one is adding more features to your decision tree. And the second part is figuring out if adding those features actually help you. Once again, if you want to look in the notebook, it will hopefully guide you down this path. If you get stuck, you can reach out to me on email. Exercise 3, you can compare the decision tree with another more modern sort of machine learning tool. You can make your own custom pipeline today. Exercise 4, bonus exercise, please contribute to this correctly. There's like maybe one person that's not here that comes in about that. So it's pretty cool. There's a lot of other resources. I co-wrote many, but not all of these books. I'm going to do something an author does not normally do. Do not buy fast data processing with Spark. I co-wrote it. It is incredibly out of date. Very sorry that it is still being sold. I still get money from that though, so if you're just buying the book as a way to help you buy coffee, that's fine. It's a very small book and it won't take up a lot of space. And it costs a lot of money as well, so it's a very good way to give me money. IBM was very clear. I am not to accept $20 bills in brown paper envelopes anymore. High performance Spark, on the other hand, is completely legitimate for me to tell people to buy, and in no way conflicts with my corporate ethics. There's an IBMer in the room that really knows what she doesn't put. So high performance Spark is more focused around sort of next steps with Spark. Most of the other books on Spark are very much like, hey, what's up? Do you like big data? I like big data too. Let's be friends. And this is the like, I tricked you into using Spark. Here's all the things I should follow. And right, so there is a raffle for one free copy. The rest of you can buy it. There's this really nice, scrappy Seattle bookstore. I really hope they'll give them a shot. So you can buy it from them. Jeff Bezos probably makes more when you buy one of these books than I do, but you know, Jeff Bezos needs another. Right. If you want an excuse to go and visit any of these dynasties, tell your boss that I am giving a talk. It's very important that we do business numbers. And if you tell me this in advance, I will back you up. If we work at the same company, though, the boss may not. It works a lot better when it's external and they haven't seen me say it. So these places are fun. I will be giving a similar talk at Spark Summit Europe. And I'll be talking about other things in other places. The next Conf Australia, I'll mostly be talking about what to do when you have the problem of too many people working on an open source project. Because you have a guess, part of my answer is make another one. What could go wrong? And then yeah, so that's pretty much it for me. I've done a lot of talking. You've laughed at many of my jokes. Thank you. If you like Spark testing, I have to give a talk on it in about 2 weeks. So I'm doing a survey for what people are doing for Spark testing, so that I can talk about things besides the random crap I came up with while I was pulling my hair out, hoping I didn't break production. If you're a Python user, I continue to try and trick the Spark community by letting me do crazy things with Python. And to that end, I'm always collecting UDFs for benchmarking purposes. Do not worry, if your UEF does not agree with my benchmark, I will lose it. But I will eventually see the results. So that's pretty much it. I think it's time for cookies and a wrap. So thank you all for coming.
We do a couple of questions. If anyone has questions, we do a couple of them.
We can do questions today.
What's the difference between Databricks Spark and IBM Spark? So they both are selling Spark.
How about we close the recording?